Thanks for the invitation of speaking here. I'm not Russell Davis, if some of you might confuse me for him. I'm filling in for him, and I must say that's rather large shoes to fill. So, my talk's called The Revolution Around the Corner, How the Internet of Things Changes Everything Again. First, a couple words on me. As Peter so kindly introduced, I was co-organizing two conferences. The first is called Atoms and Bits, focusing on the interaction of internet and real matter. And the second was the Cognitive Cities Conference, which was mostly concerned with how digital technology impacts our notions of cities. I'm a member of Council. Council is a European think tank and knowledge repository for basically anything IoT. And yeah, I run my own consultancy. So what is it, this fabled Internet of Things? I'm going to start out with a little illustration that appeared in Time magazine back in 2008, when the Internet of Things was cured as one of the 50 best new inventions of the year. I love that illustration and the fact that it appeared in that shape in Time magazine, because if you look at it, it makes no sense at all. No matter how you look at it, it doesn't make any sense. And this is pretty much the state we're in with the Internet of Things, because so many people work on it. This is such a fluid environment that however you look at it, you can look at a completely different field and see something that doesn't necessarily make sense. When we talk about the Internet of Things, mostly we mean stuff digitally connected. The term Internet of Things was formed in 1999, I guess. It's been around the block a bit. And was formed by the principle of auto ID design, and initially really only meant one thing, basically a database of where stuff is on the earth. And it's been meant to be stuff equipped with a chip just for location. We're expanding that concept massively, really. If you look at the Internet of Things, I'm going to show you some slides. It's a massive thing. If you look for Google image search, for instance, and look for the Internet of Things, you will find illustrations like that, which are not meant to clarify anything. They're meant to simply confuse and overwhelm you, because the notion is the Internet of Things is going to eat the world. The Internet of Things is going to eat everything, and it's going to be huge. So huge, in fact, that we've heard that a couple of times ago already, that there are already more non-human users on the largest American networks than human users. This article is from February 2011. As I've heard from Andy Hobsbawm yesterday, the threshold where we kicked over to being the minority was actually August 10th, 2010. If you look at the projections, this is just thrown in there to further illustrate how many devices we're talking about. I really love IBM with 1 trillion devices by 2015. That's a lot. And if you calculate that on a per capita basis, we're talking at least 3.1 devices per person on the planet. That's the whole planet. That's not me and you with our, I did a count in my household with our 5.5 internet connected devices per person. So that's a bit on the statistics. What do those devices actually look like? What does it mean to have an internet connected device? I always come back to that, and this is the Nest Smart Thermostat. That it is a thermostat is pretty obvious from the shape of the object. And I love it because it clearly communicates its purpose. You can clearly see the design intent in this object, and From here, I really could have this talk go into multiple different directions. I could talk about the importance of good design, how important it is, especially if you design for an audience that is spoiled by Apple-like perfection, to have every step of the experience, and that is steps as small as how you apply the wires when you install the device. How crucially important that is for the acceptance of a device. Or I could go on about the disintermediation of interfaces. You see, when you set up the Nest, once it's set up, you never actually have to use the device anymore, because all the device can do, you can do on your smartphone. You don't actually have to use the thermostat to use the thermostat. But what I'm really interested in, and I was just talking about the design intent behind this device, is what differentiates this object from this. And I'm fairly certain you kind of know what that is. This is the fabled internet fridge. The internet fridge is not created with design intent. This is pure gizmo land. This is how do we integrate this Venn diagram of whiteware, a fridge, and the internet. This concept has been around a while. It's almost even as old as the concept of Internet of Things. If you look at this, for instance, this is the LG Internet fridge from 2001, I believe. You wonder why it didn't stick? Well, first off, there was a price. This device would have cost you $20,000 back in the day, and rightfully has achieved epitome status for the dot-com bust. We can talk about plenty more devices which stray into that area, which I consider delineates objects like that from objects like that by simply stating, objects like that try to make things better by adding digital capabilities. Whereas in Gizmoland, you have the pure question, and you can really feel how the design team, or rather the design team lead, was screaming around his department and said, how can we add digital to this object without any thought about what impact is going to have on the capabilities and the usage of the object. I love this example because it really showcases what I'm talking about. This is a lighting science group IPv6 smartphone-enabled light bulb. It's an LED light bulb. It's fairly efficient. It achieves the same lighting amount with, I guess it's a 20th of the energy consumption of a regular light bulb. And you can control it with your smartphone. This was showcased about a year ago at Google I/O, where the department head for Google Android went on to the interview and said, we'd like to think of your entire home as an accessory, or better yet, as a network of accessories, and think of Android as the operating system for your home. And this is Gizmoland I was just talking about, because to control this, you have the interfaces already. You know how to interact with the world. And that is why I think the idea of an overwhelming Internet of Things is so dangerous, because it leads to notions of controlling your home with your smartphone, whereas your home should control your smartphone. Another example of simplicity and purpose-led design intent, which I really love, and this is a product I almost always integrate in my presentations because it's just so cool. This is a IPv6 enabled pill bottle. Why that, you might ask first, but the purpose gets immediately obvious if you look at this image, for instance, because this bottle will remind you to take your pills. And it will do so in several stages of escalation. It will start with blinking lights at the base station, but behind that is actually a pretty clever social feedback design. So if you don't take your pills 2 hours after the light started to glow, somebody from the company will actually call you and ask you whether you would want to take your pills. You can set up a trusted network of friends and family where you can send monthly reports to how your compliance with your medication works out. You have a pharmacy integration, so when you run out of pills sufficiently in advance, it will resupply you with your pills. And you have accountability with your doctor. First off, your accountability, you're in charge of your own compliance, but your doc knows what's going on. He can treat your symptoms way better because he knows whether you've been medicating or not. Another huge example is this. It's a body scale that communicates with the internet. And when it first came out, I saw all those applications, and I was thinking they're just goofing around. I mean, come on, it's your weight on Twitter, and this is a tweet that goes out once weekly. But this is the necessary part of experimentation which you have with any new technology. What really makes it interesting is this, because it really helps you with what you want to achieve if you step on a body scale anyway. This is technology making your life easier. Because the one job a customer wants to have done when he's stepping on a body scale is to get his weight and ideally graph it over time to see development. That is something that technology can do for you. There's no reason why you have to bother with that. And in effect, because you don't have to bother with that, you tend to do it more regularly, and then there comes the Heisenberg effect of design and quantify itself. By just measuring it more regularly, you're actually achieving positive results because you're bettering your weight. But this is only still the beginning of what we're talking about, because if you integrate that with, there's plenty of these examples. This is the Jawbone app. This is, which I've seen a couple of you around wearing. This is the Nike Plus Fuel Band. This is the Fitbit. Those pretty much all do the same thing. They track your motion, they calculate a calorie count, and if you do it right, you can track it against your weight and have a pretty good workout regimen. You know what you're doing anyway, and you know where you should do more sports. And they track your workouts, which is pretty cool. This is a bike ride I did just the other day. The funny thing about this bike ride is that it didn't use any of those gizmos. It used the gizmo that's probably most prevalent and most ubiquitous of all in this conference and a lot of tech conferences, and that is your smartphone. A good friend of mine spoke at another conference and basically equated the smartphones with city samplers, because that's what they do. They constantly take inputs. This is the iPhone 4S. This has 13 different sensors, which constantly take in information, which constantly sample that information. I don't know exactly how much they're sending back, how much is processed locally, but I can do a whole lot of information processing and storing with that. This is really not what's so cool about the iPhone. What's so cool about the iPhone is the possibilities that come with it. You have a computation platform, you have sensors already, and you can pretty easily integrate new sensors. So this is a prototype of a device called the iGeigy by Jean Bonnet, co-founder of Safecast. And devices like this and others like it were used to sample that. This is the so-called Japan Geiger map, compiled by Haiyan Sung. She's an interaction designer with IDEO London. And what they did was basically accumulate all the data that volunteers accreted after the Fukushima disaster in Japan and made it humanly intelligible. What I love about that is that it's sensors. It's stuff like that, experimentation in the field with the technology you have, that in this case forced the Japanese government to acknowledge that indeed there was a high radiation risk in the area. But we don't have to necessarily to talk about radiation, which is a tough topic, especially when we talk about it in Germany. But other kinds of information that gets sampled and accreted just by interacting with the devices you already have. For instance, this is Google Traffic Overview. And the interesting thing about Google Traffic Overlay on Google Maps is that by using it, I make it better. How this works is they partner with cell phone manufacturers, and they know exactly how a regular traffic pattern looks like. So they know on a regular day like that, at that time, there's so many cell phones moving through this cell tower. If they're not moving in the speed, or just standing still, you pretty much know that you have a traffic jam at your hands. And this is where we really start to talking to the machines. This is a screenshot of a service called Drive Now. I just joined about a week ago, pretty much for this conference, because I like this app so much. You're there. All the blue dots around it are cars, which I could walk up, hold an RFID tag against. You remember this little chip I showed you in the beginning? And just open it and drive away. This is cars on the internet. How cool is that? So there's plenty of examples on how the Internet of Things might look like. But I'm pretty sure you still think like this image, because it still doesn't make any sense. I mean, the Internet of Things is pretty much a foregone conclusion. That's why I was so intent on making the distinction between adding digital to stuff and making stuff better by digital. Because you have 3 laws of computation. There's Moore's law, which posits that the number of transistors on the same area of chip doubles every 2 years. It's been remarkably stable since 1971. Please note this scale is exponential. The consequence of Moore's law is that your chips get ever cheaper and ever more powerful. So I don't have my phone up here, but there's this nice image of your 2010 iPhone compared with your 2000 iMac. And your 2010 iPhone is actually both cheaper and more powerful. Then there's Kumi's law. So we now know not only get the chips cheaper and more powerful, they get more efficient as well. Kumi's law is another remarkably stable law, which says that the energy efficiency per unit of computation doubles every 1.5 years. That means I can do the same amount of computations for half the amount of energy I put into a chip. In other terms, if you took a modern day MacBook Air and applied 1991 energy efficiency standards to it, fully charged that the battery would be drained within 1.5 seconds. And that's the development we've gone through in a mere 20 years. So those 2 laws add feasibility to the fact that we can put chips in pretty much anything we want. Now, why would we want to do that? And that's the third and crucial law. That's Markov's law. It was coined first, I guess, in the 60s, early 70s. And it basically just says that the value of a network grows exponentially to the number of its nodes. This law is the reason why telephone networks are so insanely valuable. This law is the reason why Facebook is aiming at a $100 billion valuation when it IPOs in a week or 2. And this is the reason why we have strong economic, we have a compelling economic incentive to implement chips into everyday stuff. Because we can, and the value of the network increases. And in fact, we're already doing. This is a Raspberry Pi. It's just been released about, I don't know, a month, 2 months ago. This is a credit card-sized ARM computer. You can run Linux in it. You can run your TV with that. It can output HDMI video perfectly fine. It's a full-sized computer. You plug it into the TV, you plug it into a keyboard, and you're good to go. And here's the coolest thing about it. It costs $35. Needless to say, this opens up the space for experimentation, because a computer that cheap, you can basically do anything with that. Here's another example that's been around for about a decade, the Arduinos. Those are the things that really got hobbyists working, because you can do so many cool stuff with that. This is, for instance, London has a bike sharing system called Boris Bikes. If you're from Berlin, you might know that from the Deutsche Bahn bike sharing. The cool thing about Boris Bikes is that you have an online database of where the bikes are, whether they are available or not. However, it's really cumbersome to look up before you head out to get to work or wherever you need to go. So, a London project, and I'm glad to have the initiator of the project here. And a participant of the project created this bike map, which basically shows which station he should head to when he's heading out his flat, because there's bikes available there. And it's that layer of experimentation in the Internet of Things that really gets me excited about it. Here's another example out of London. It's called the Air Quality Act, and it basically tries to build on the Safecast map, the Geiger counter map I've shown you earlier. Because that's going to be low-cost energy monitoring, air quality monitoring devices, which you can put on your roof, which you can put in your parking lot, wherever. This is democratized data sampling. The idea is to have maps like that. We can do that because of the 3 laws, and it's getting ever cheaper, and it's getting ever more feasible. What we need to have in mind is that just because we can, we shouldn't just add digital to stuff. We should think about how we can make stuff better by adding this digital, because we need less of this and more of this. Thank you very much.